Hello everyone. So today's video topic is about linked list. Okay. So I am trying to implement doubly linked list by using class module. Okay. So if you want to know what is linked list, then you can go to this Geek for Geeks website and try to understand. So basically a linked list contains two data. If it is simply linked list, so it will contain the data, and the next one is the pointer. Then the pointer is containing the next node address. Okay, so it's called a node, and in this node A is the data, and this one containing the address for the next node, and so on. This one is data, and this one will contain the address for the upcoming node. Okay, and for in case of doubly linked list, then there is two addresses. Okay, so basically this one or if I talk about this one, so this will contain two address. One is the next node address, so it will be null if all these are not added yet, and this will contain the previous node address, so that you can traverse forward and backward. So you can go from A, B, C, D or D, C, P, A. So that's why it's a doubly linked list. You can go from start to end, or end to start. Okay. So basically this is the linked list. So each node contains three elements. So first one is previous node address, second one is data, you can think like this, and the third one is the next node address. Okay, so for that case we are using a class module that is called node, and you can see that there is three private field. The first one is p data as variant. I am using this variant, but based on your needs you can use any data type. So, and the next one is next node address and previous node addresses. Okay, so for add data, let p data equals to value. So here you can add some data validation, or you can check if it's a valid data or not, but as it's a variant, so it doesn't going to insert that properly, but you can add this add on your end. And this is get data, so it's a property let and get, and as both this please take a look at this, that class name is node, so p next node address is also node, and previous node is also a node, so it's a self-referencing classes. Okay, so this point p next node address is referencing uh, instances of node classes and so on, and then that's why we need to use set instead of let from let property. So let next node address, and we are just uh, pointing to this one and this one. Okay, so basically this is just let and get, but you can just keep up to this three field. These three are necessary, and this is for actually validation if you want to validate the data. And another class that is called linked list, which will implement the linked list. Okay, and it will take the help of this node class. So now here we have this head pointing node, head as a node. So if you look at this, so head is pointing to this one always, and previous node as node. So basically I did this to keep tracking of the present node, or the last added node, so that we can add the next element at O on times without looping through from head to the till the last. Okay, and then again that private p counter, so I'm counting how many element is added so far. Okay, so this is a method called insert. So if you want to add a new value, so it will take value as parent. Now I'm declaring or creating a new node, as a node and setting that new node as a this class instances of these classes. Okay, so instance of this class, and new node data is data.value, and new node is always going to point nothing because we are inserting at the end. We can insert at the beginning, we can insert at the given index, so I will implement those later on. And we are adding element at the end, so it will always pointing to nothing. Now we are checking that if head is nothing or not. So for the first time, head will point to nothing, or we can check that if p counter equals to 0, so still it's represent that we didn't add any data so far, so head is nothing or not. So if head is nothing, so we are just adding the first element, right? Then new node, so new node dot previous node address will be nothing. As you can see that the first element or first node address, previous address will be always nothing or null. In this Java it's null, but in VBA it's nothing. And last element next addresses, node addresses will be null always. So let's try this one. Next node address is always nothing, and for the first time the new node dot previous node address is always nothing. And so as this is the first node, then we need to set this head. Okay, so this head, and then set previous node, so it will always add the new node as a previous node, so previous node equals to new node. And if that is not the case, so for the second time when we are going to add the second element, so if I run this, so now you can see that we already add the first element, and now we are going to add the second element. Okay, so if you can see that p counter value is 1 because we already add the element. So for the second element, what we need to do that the previous node next node address was nothing, right? So for the first time when we add this data in this place, so next node address was nothing. So what we need to do that we need to point this one to the newly added node. Okay, and then we need to link the newly added node previous to this node, right? The previously added node. So that's why we are saying that previous node dot next node address equals to new node, so it will pointing to this new node. Don't be fool like me in that I'm setting that new node dot previous node address equals to previous node. So previous node next node address was nothing, so it will always be nothing, so you cannot traverse from the beginning. So you need to set first the previous node next node address. Okay, so the first element, sorry, so if you need to first set this first element next node because it was nothing, so you need to update this one first and then you need to link this one. Okay, so that's it, and then we are just setting this previous node equals to new node because it will always go with the added node, so it will always pointing to the previous node. Okay, so that's it, and we are increasing that counter plus 1. So if I run this, now already 2 element is added. Now you can see this that p counter value is 2, so already 2 element is added. Now in this place you can see that show from beginning, so we already add all these element, and then we are saying that we need to show all the element from the beginning. Okay, so what we need to do, we need to declare another variable as node type, so temporary as node, and temporary will be pointing to head because we are traversing from the beginning. And how do we need to do that? Until this temporary dot next node address is not nothing, then we need to keep running the loop, right? So that's why not temporary dot next node address is nothing, and counter, we are increasing the counter because we are printing this, and that node number is counter and value is temporary data. And set temporary a node to the next temporary next node address. So for the first time we run this. Sorry. Now temporary is representing the first one. Okay, so it will print the first data. So it's print this first node value. Okay, and if I run this, now we can see this, the temporary 2 or node 2, actually node 2 value is 10. So okay, and node 3 is value is 15, and node 4 node 5. Okay, maybe if I see the p counter, so there is so p counter, so there is 7 element, so we have print so far 5 element, and this is 6th element, and for this you can see that it skipped the row as it's pointing to nothing. Okay, but still we need to print the next node addresses. So why is that? Because we are just setting the temporary next node address, so it's already reached to the end, and then we are checking that if it's pointing to nothing. Yes, and that is pointing to nothing, and then we are just printing the last element here. So that's it, and then end. And we can traverse from beginning to if you want. So when we are we need to traverse from the last. We already traverse from the beginning, so in that case we need to set the temporary equals to previous node. Okay, so it point to the last node, so we need to just say this, the temp equals to previous node, and so one we can just print this data. So if I show you the linked list tester, so at first we are adding or inserting 5, then 10, then 15, 20, 30, and then my name, and then today date, and then we are just printing. Okay, so if I run this, get rid of this, now you can see this, that node 1 value is 15, node 2 value is 10, so 1 and node 15, 20, 30 is smile and today's date, and then we are printing from the end. So at first it will come to the date, and then a smile, then 30, 20, 15, 10, and 5. So you can just easily add node at of 1 times complexity, and it's better that if you want to remove node, you can easily remove the node at O of 1 or constant time. But in case of array, if you want to remove a node or a element, then you need to shrink the array. Okay, you need to redeem that, but in this case you don't need to redeem that, you just need to set the pointer to a specific section and it will be okay. So that's it. Okay, thank you. If you have any query, please let me know. I don't know if I explained it clearly or not. So if I add another double linked list, insert, Valentine's Day, if I run this, okay, that's good. So now date, and this is good. Sort RL item, I'm just saying that w.count, and show from last, show from beginning. That's it. Okay, bye bye.